In Star Trek, Starfleet is the exploratory and defensive force of the United Federation of Planets. Starfleet's most important rule is the Prime Directive, which dictates that no Starfleet personnel should knowingly interfere with the natural progression of pre-warp civilizations. The warp drive is faster than light space travel technology, allowing users to traverse vast distances between stars in a short amount of time. Pre-warp civilizations have not yet invented the warp drive, and thus are not deemed developed enough to join the Federation of Planets. So, members of the Federation keep themselves hidden from these pre-warp civilizations. Could our galaxy be home to a similar galactic club of aliens who have purposely hid themselves from Earth? Where does science stand on this topic? Greetings, Earthlings. Welcome to Science Fictionally True. I'm your host, Jimmy. On this channel, we talk about the science, technology, and history behind science fiction topics. We also discuss current events about aspects of our society that are moving from science fiction to science fact. This is the third episode in our Fermi Paradox series, where we'll discuss another class of Fermi Paradox resolutions, the possibility that aliens do exist, but just haven't visited Earth. First, we'll go over the hurdles an alien species must overcome if they want to visit their interstellar neighbors. Then, we'll discuss reasons why aliens might not want to visit Earth even if they could. Again, the topics covered are based on scientific discoveries or were proposed by practicing scientists. A significant portion of the general public believe Earth has been visited by aliens. However, most scientists believe this is unlikely. Instead, they believe aliens do exist, but just haven't visited Earth yet. The primary reason is because stars are too far apart, making interstellar travel difficult. For example, the closest star outside our solar system is Proxima Centauri in the Alpha Centauri star system, about 4.2 light years away. This means light, the fastest thing in our universe, takes 4.2 years to travel from Earth to Proxima Centauri. That's about 40 trillion kilometers, equivalent to going to the moon and back about 50,000 times. The next closest star outside the Alpha Centauri star system is Barnard star, about 6 light years away, and the prospects of interstellar travel get dimmer and dimmer from there. However, just because interstellar travel is difficult for us today doesn't mean that it's unattainable. In fact, humans are already planning to send space probes to Proxima Centauri to study the star and its nearby planets. The Breakthrough Starshot program, funded by tech entrepreneur and billionaire Yuri Milner, wants to make the trip using miniature space probes with light sails attached, called nanocrafts. First, they will launch a mothership carrying thousands of nanocrafts into high-altitude orbit and release the nanocrafts into space. Second, an array of powerful lasers on Earth will shoot at the nanocraft's light sails. The laser photons will be reflected by the sail, and a portion of their momentum will be transferred to the light sail, propelling the nanocraft forward. The scientists and engineers of Breakthrough Starshot expect that the nanocrafts will reach their target speed, about 20% the speed of light, within minutes. They expect the nanocrafts to arrive at Proxima Centauri 20 years from launch. Once at their destination, the probes will beam home pictures of Proxima Centauri b, a potentially habitable planet orbiting Proxima Centauri. The probes will collect other scientific data about the Alpha Centauri star system too while on their flyby. Because the scientists and engineers expect to lose many nanocrafts during the mission, they will release thousands, hoping a few will successfully traverse the journey. We may witness this event within our lifetimes. I can already hear some of the viewers saying, but I don't want to send just some unmanned space probe to another star. What if I want to visit the star myself? Don't worry, we will have an entire future episode exploring the possibility of shuttling humans across interstellar distances, so please tune in when it's available. A question naturally follows after knowing we're on the verge of achieving interstellar space travel. If we're able to send interstellar probes, then advanced extraterrestrial civilizations keen on colonizing the galaxy should be able to as well. So why haven't we seen any signs of them? Astronomer Michael Hart was the first to put forth this question. He assumed that technologically powerful aliens wanting to colonize the galaxy could do so with a colonization wavefront speed of 10% the speed of light. Hart defines the colonization wavefront speed as the speed colonization ships are spreading out throughout the galaxy. At this speed, one can travel from one end of our galaxy to the other in about 1 million years. This is a relatively short time when compared to the lifetime of our universe, about 13.8 billion years. In the first episode of our Fermi Paradox series, we used a universal year analogy to wrap our heads around astronomical timescales. Using that analogy, 1 million years is equivalent to 38 minutes and 20 seconds in our universal year. That's barely any time at all. Advanced alien civilizations could have arose in springtime of our universal year and quickly colonized our galaxy. Humans, which popped up in late December of the universal year, should have encountered signs of their probes or colonization ships. So where are they? Many scientists have disputed the validity of Hart's model. Firstly, they argue the colonization wavefront speed is too optimistic. Astronomer Carl Sagan once said, "Rome wasn't built in a day, although one can cross it on foot in a few hours." In other words, spacecrafts from a colonizing extraterrestrial civilization could move at 10% the speed of light. However, their colonization wavefront would be much slower. Taking our own human history as an example, there has never been a colonization wavefront that moved as fast as an individual craft. Secondly, Hart calculated the colonization time simply by dividing the diameter of our galaxy by the colonization wavefront speed. That assumption is too simplistic, and several scientists countered by proposing more sophisticated models. For example, astronomers William Newman and Carl Sagan modeled galactic colonization like diffusion. Diffusion is a physical process in which energy or matter flows from a point of higher concentration to a point of lower concentration. A simple example of diffusion is when you put a cube of sugar in a cup of tea. If you stir the tea, the sugar will spread out from the cube, a point of high sugar concentration, to the rest of the tea, points of low or no sugar concentration. Eventually, the sugar will be uniformly distributed throughout the tea. Like the tightly packed sugar molecules that eventually spread throughout the tea, a colonizing alien species would leave their home planet and spread out throughout the galaxy. Using their model and making some assumptions, Newman and Sagan calculated that the nearest civilization would reach Earth only if it had a lifetime of 13 billion years. This would explain why no one has visited us yet. There have been other scientists who have come up with even more sophisticated colonization models. However, many have still critiqued them for not capturing the reality. Instead, they offer a slew of alternative reasons why Earth hasn't been visited. Throughout the series, we implicitly assumed that aliens would find our Sun, a stable G2 type star, and Earth, a rocky planet covered in liquid water, ideal places to establish a colony. Earth is the only place in the universe we know for sure can support life. So we assumed aliens would like to set up camp in places like our planet and solar system. However, colonizing aliens may be looking for something totally different. Astronomer Freeman Dyson hypothesized that advanced extraterrestrial civilizations may want to construct Dyson spheres, or hypothetical megastructures encompassing a star that captures a large part of that star's solar energy. If aliens employed this strategy, they would want to construct Dyson spheres around the most luminous stars and set up colonization bases there. For example, O-type main sequence stars are 40,000 to 1 million times more luminous than our Sun. So, colonizing extraterrestrials may not want to visit our solar system because it's not economically advantageous for them to do so. Another more sobering reason why aliens haven't visited us is because it's too resource intensive. Many of the galactic colonization models scientists have proposed mirror human colonization of Earth. Humans are a widely successful species. Of all the species that have existed on Earth, literally 99.9% are now extinct. On the other hand, if we look at a graph of human population over time, we'll see an exponential trend. The curve really begins to take off around 1800 amidst the Industrial Revolution. It took from the inception of our species to 1800 to grow our population to 1 billion. However, in a short 200 years after that, our population grew by about another 7 billion. This exponential trend is a hallmark of human ingenuity. We've taken control of our environment and molded it to fit our needs. But as amazing as this trend is, it cannot continue forever. So what will end it? Maybe we simply run out of resources. After all, Earth's resources are finite. Even if we venture out and mine our solar system, those resources are finite too. If alien populations suffer from similar constraints, this could explain why we don't observe any fast-growing extraterrestrial civilizations in our galaxy. The ones that grow fast may also die young, so we don't ever see any of them. If there are alien civilizations colonizing the galaxy, maybe they're colonizing it in a slower but more sustainable way. The last reason we'll discuss for aliens not visiting Earth is the zoo hypothesis. Before I get into it, I want to make a disclaimer. Scientists try to explain the unknown by proposing explanations or hypotheses under the expectation that they'll be scrutinized with empirical data. The zoo hypothesis is a misnomer. Unfortunately, the zoo hypothesis is not actually a hypothesis because it cannot be tested. Therefore, it is not scientific. With that being said, however, it doesn't mean that the zoo hypothesis is illogical or unlikely. The zoo hypothesis goes like this. First, it assumes that extraterrestrial civilizations are ubiquitous throughout our universe and that some civilizations will develop their technology over time. The most advanced civilizations will be in control. The less advanced civilizations will either be destroyed, tamed, or assimilated. If this is the case, how will powerful civilizations choose to exert their power? Earth and our solar system may be located in a zoo set aside by powerful extraterrestrial civilizations. This would be similar to how humans set up wilderness sanctuaries or zoos for various animal species on Earth. Why powerful aliens would do such a thing is anyone's guess. Whatever the reasons, these powerful aliens don't want to be found and have the technology to ensure they stay hidden. Maybe their moral code prohibits interfering with the natural development of living organisms outside their home world. We touched on this concept at the beginning of the video with the Prime Directive policy in Star Trek. The Prime Directive dictates that the members of Starfleet don't have a right to alter another biosphere and that they should go to great lengths to ensure non-interference. In a way, humans actually share the same moral code. While on its mission, the Cassini space probe discovered a liquid water ocean under the icy surface of Enceladus, one of Saturn's moons. This means Enceladus potentially contained native life. So, NASA deliberately crashed Cassini into Saturn, letting it burn up in Saturn's atmosphere. This prevented an accidental crash landing into Enceladus and contaminating it with Earth microbes. There are many criticisms against the zoo hypothesis. Firstly, we'd be unable to peek through the zoo's veil of secrecy. And unfortunately, if a hypothesis cannot be tested by making observations, then it's not scientific. Secondly, people criticize the zoo hypothesis for being anthropocentric. Why would a powerful alien civilization be so interested in us puny humans? Lastly, the most important criticism stems from the assumption that extraterrestrial civilizations are ubiquitous in our universe. Well, if that's true, then it only requires one rogue civilization to reveal the charade to Earth. And of course, that hasn't happened yet. What do you think are the reasons why aliens haven't visited Earth? Please let us know in the comments below. Aliens don't need to visit Earth for us to confirm their existence. Believe it or not, scientists have been trying to remotely detect their presence for decades now, yet we still have no strong scientific evidence for alien life. Please tune into the next episode, where we will continue our 5-part Fermi Paradox series by discussing another class of Fermi Paradox resolutions, the possibility that aliens do exist, and the reasons why we haven't made contact yet. Again, The reasons covered are based on scientific discoveries or are proposed by practicing scientists. If there are any topics covered in this episode that you'd like to explore further on your own, sources are given in the video description below. If you enjoyed this video, don't forget to hit the like button. Please subscribe to my channel and hit the bell to turn on notifications so you'll be updated when new videos are posted. Also, please let me know in the comments if there are any topics you'd like me to cover in future videos. See y'all next time.